So welcome everyone. We're going to be making a 2D game. What I've got right here, oh my god, if this thing would just go away. I hate Zoom. I hate Zoom. There we go. So this is a little something that I whipped up. It's gorgeous, as you can see. You've got a player character that can move left and right. I'm calling him Mayro. He can shoot fireballs, which are just Sprite cans at the traffic cone that you can jump on, kill. There's little power-ups like right there. So like that's like the super mushroom in Mario Bros. So now that he's a Zoomin, he can actually take a hit and survive. Whereas normally he would, oh, I'm still in my invincibility frames. Now I'm dead. And generally what we're going to be doing today. And then you can see like how we've got background, sprites, just in general, how to set all this up in a 2D game. So I'm gonna take inspiration from Blaine and kind of keep the finished version on my other monitor while we go through a new one on the one I share screens with. So to start off, we're gonna be new project in Unity with whatever version you have. We're going to be selecting 2D, and then the project name we can call it programming 2D. There we go. Create. And so what we are going to start with setting up the scene first. So I would say the most important thing about making a Unity is that it's basically the same exact thing as 3D, except you're just ignoring an axis. So as always, you can the object like the cube, and then you can move it around. If you press this little button that says 2D, you'll actually toggle between the 3D and the 2D views. And so that's helpful for debugging if you have things starting to like get off your floor and whatever. You can move around the scene in 3D and figure out what's going on. But we'll stick in 2D because it's nice and easy to editing in. And so right now I'm just gonna make a floor so we can actually move around in our test area. And that's just made with a key. I'm going to center the key. Oh, I didn't want to do that. I just wanted to center it. There we go. So we're making a cube, and then I'm going to make a capsule. And if you attended our adventure game workshop, then we're going to be making things that are very, very similar to what we made then. We're going to be making a character that moves similarly. We're going to be making enemies that move similarly, because 2D is just 3D axis. And so it's helpful. So this is going to be our character. This is our character capsule over here. I'm going to name them player. And so in order to move, we're going to have to create a script. And I'm just going to name this player movement. And then we're going to, oh, that didn't open it. Come on, open it up. There we go. Oh, player movement. All right, and so I'm just going to remove the default start and update methods because we don't really need them right now. So when we're making the player, we need to think about what do we need to make movement. We're going to need speed, which I'm just going to initialize with a default variable of 5. As we've done before, we're going to have a rigid body. That's what gives us physics. Player. We're going to want to jump, so we're going to need a jump height. For now, let's leave it at that. So the next step is we are going to bring out our update method, but I think we've mentioned this before. We like to use fixed update because fixed update prevents you from having those glitches that we discussed. Like if your frame rate's super fast, then the game runs super fast. Fixed update stops that. So in order to get the player to actually move, we're going to set its velocity based on the horizontal axis input. And so we're doing velocity equals new vector3, input dot get axis, horizontal times speed, so that way we can make them go faster. Dot velocity dot y, and then I'll explain this in a second. And so what this is doing is this is just setting the velocity equal to the input based on the, so when you press A or D, this value is going to change. We're multiplying it by speed. So that's what gives us like the magnitude of movement. We don't want to change Y or Z. We just want it to be like as it currently is. So we're just leaving that alone. And then let's see. And then also like how we did during the Zaldi workshop, where we want the player character to rotate in the direction that it's going to move. So we checked it. Object.transform.rotation to be equal to Quaternion rotation. So what this is going to do is when our velocity in the x greater than 0, we're going to be looking to the world's right. And then if our velocity is less than 0, we want to be looking, I'm just going to copy this line of code, in the opposite of the right direction, the left direction. And since there's no like vector 3 dot left, you just have to put a negative sign there because the negative vector is just the opposite direction. Cool. Let's do jumping now. Before we can do jump, we want to create ground check because we don't want our character to be able to jump up and continue jumping infinitely. So let's create getting out of fixed update just for a second. I'm going to do private bool ground check. And to do ground check, first you need to set the diff of, so the way ground check works is we send a vector down into the ground, and we just detect if there is something immediately below us. The length of the vector is going to be 1.01 because 1 is about the size of our character, and then the 0.01 allows us to dig deep into the ground just a little bit. And so we set the distance to be 1.0. We set the direction to be a new vector 3 in the direction 0, -1, 0 is our y-axis is our up and down axis right now. And then we return 6 dots. Position, distance. So this does is you set the origin, which is the player position. You set the direction, which is the direction vector that we created, and you set the vector that we're sending down, which we set to be 1.01f. And then when we return this, essentially what it does is physics.raycast true if it hits something and it returns false. If it doesn't hit anything, So whenever this returns true, we'll know that we are currently standing on top of it, and that will be very helpful when we want to jump. And so then fixed update, we can now do if input.getKey key code. Oh, that's the wrong button. That's the wrong one. We're not doing mouse. We are doing space. So what this does, this will tell us if we are currently pressing space. So if space, then we do uncheck. And so this will return true if there is something below us. The velocity equal to a new vector 3. So now this is kind of the opposite of what we did up here, the y velocity, because we want to jump. So we keep the x velocity the same. We put our jump height in there. And then we do player.velocity z, because we're not changing the z velocity. So that's that, that's that. Let me make sure that I've got. Cool. And so this is all the player movement. Now if we open up the editor, we go to the player and we put the player movement script component. Oh, stop that. We want to drag, oh, I forgot the rigid body. Rigid as well. You put the rigid body into the player field. And so now he should be able to move around when you press left and right, or A and D, and jump when you press space. And he's going to start turning. He did not constrain the rotation, so make sure you do that. And then I would also recommend position in the z-axis, because we don't want our character to like fall off this little beam that we've created for him. What does vector 3? Vector 3 is a three-dimensional vector. So if you've taken like calculus, you should be familiar with vectors. They're arrows that go in a direction in 3D space with x, y, and z coordinate, and they have a map. And so a vector 3 is just a representation of a vector. Yeah, let's continue the player. Let's continue the player. I think that's a good idea. So just like Mario, we want Marrow to be able to shoot fireballs. So in order to do that, we need a projectile. And so if we do public game object projectile up here where we're defining our variables, this will allow us to put a prefab in for this variable, and then when we spawn it, we're just spawning the prefab that we put in. When we shoot, we also want, actually, I'm just gonna leave that there. I'm gonna leave that there, and we'll the consequences of something later on. So give me a second. Here we go. So if we go back into the fixed update, you can do if input.e key code dot mouse 0. This will be your left mouse click. You can then do game object. I'll explain what this does in a minute. So what this line of code is going to do is this is just going to instantiate the projectile prefab in there. And so I want to show you guys, because I was doing this with Will earlier, and it's pretty fun. So back in the player, oh, I don't have a prefab. Yeah, let's create the projectile prefab. I'm jumping around a little bit. Sorry about that. We're back in the editor. in the hierarchy, you're going to want to create a 3D object, and you want it to be a sphere. I would recommend putting it at 0. And I would also recommend scaling it down a little bit because you don't want like giant fireballs. This is our sphere. You can see it right there. We want the sphere to bounce, so we are going to create in object window a physics material, not physics material 2D, because remember these objects. So the new physics material, you can call it bouncy. And we want the bounciness to be, I think 0.6 is a good one. And then, what did I do?
Is maximum.
Okay, cool. So these are the settings I'm using for the bouncy. You can mess around with these if you want. You can make it more bouncy. You can make it less bouncy. It's fun to play with. And so then back on the sphere, in the sphere collider, you're going to want to put bouncy in for the physics material. And so what this will allow it to do, and you can even test it out if you really want, is it'll give it a little bit of a bounce when I didn't put. So in order for gravity to work on it, you also want to put the rigid body on it. And that will just default with the gravity. You'll see that the sphere bounces a little bit. Put that back at 0, 0, 0. And then I'm also going to freeze the position in the Z because we don't want it going outside of the axis that we've created. And so now if you drag the sphere down into the project window, that creates the prefab that we want. And then if we go over to the player and we drag this prefab over to the projectile field, and we play, this should work, and you click, it just spawned a ton our projectile. And if you hold down, it'll just keep shooting. It's absolutely gorgeous. If I can just get out of play mode, thank you. I'm also going to get rid of that. Okay. It is a good use to launch yourself up, yeah. But we want the projectile to actually be a character. So we're gonna specify a couple more things in here. So in the ball, and we have a reference to it now because that's what GameObject_Ball does. It allows us to refer to it. And so we want to change its position, ball.transform.position. This allows you to access the position of the ball. You can set it GameObject.transform.position. So what this GameObject.transform.position is, this is the GameObject script is attached to, so the player object. It's transform, which is the position, the rotation, the scaling, and then you access its position. So if you hit here, this would spawn directly in the center of our player character. We don't want that, so we're gonna add a little something to it. Object.transform.forward. This is the forward vector. Every object has a forward vector or a right vector, which if you imagine vectors on yourself, the up vector is coming out from your head, the forward vector is coming out of your face, the vector is coming out of the right side of your head. And so the forward vector is just gonna point directly out from our player character. And we're just gonna multiply it by a little bit so it has more of a magnitude. And so this is what we want. So what this will do is this will put the position at our center of our character plus forward a little bit, so that way it's spawning like right in front of our character. Then we want to, actually I'll show off with this Feel free to try this out if you want. I just kind of want to show exactly how this works. You can see it spawns like right in front of us. But the force isn't coming from anywhere. It's just kind of like hitting itself, and they're all spazzing. So we want this to actually be shooting out. So now we are going to do ball dot get component rigid body. I got marked out the platform like forward or behind it. Yeah, that happens. As long as you just unpress play, you'll be good. So ball.get component rigid body. Add force allows us to put a force on our projectile. Yeah, we're not currently catching for any errors. We'll handle that stuff later. You want to add force. Look at locking position. Game object dot transform dot forward. I'll explain what the stuff I'm typing is in a second. We're doing here. It's a couple math steps in one. We're adding a force that is going to be. So imagine a vector coming out of the forward vector coming from the player. We're multiplying this by 2 to make it bigger. Then we're subtracting the up vector. So if you have a vector going horizontally, and you a vector that's going up, you have a vector that's kind of pointing diagonally to the lower left or lower right that you're facing. And so this is how we get our diagonal Mario fireball kind of shooting. And then this would be a unit vector or somewhere close to a unit vector. So we want to give it a little bit more magnitude so it has some oomph. And so that's why by 300. Yeah. So then I'll show off what that one does. And so now you can see for a little while, it starts shooting out until the balls just keep coming. But we can stop that. That by doing a rate of fire. So going back up to our variables, if you do public rate of fire, and I'm just going to set it equal to 1 for now. And then we also want a public last fire time, and we're just going to not set that. You can now do in here, if the current time, which is time.time, is when the last fire time plus the rate of fire. So this is a way to limit things from happening super duper fast. So if the current time is greater than the last time you fired off a fireball, plus a little bit of extra time that allows you to have a wait, essentially, we can do all of the stuff that we put in the code. So you just kind of encapsulate it in there. But if we don't ever set last fire time, this doesn't do anything because this is by default 0. And so as long as the time is 0 plus 1, it won't matter. So now we have to also set last fire time equal to the current time. And so then every time you shoot, it'll update last fire time, and you'll have to wait for rate of fire seconds before you can shoot another one. And also, just to add a little bit more stuff, you don't want the fireballs to just kind of be sitting on the ground. So you're going to want to destroy the ball. Then you can add another parameter here for the number of seconds you want the ball to exist. I found 1.5 to be good. If you want it to last longer or shorter, go ahead and do that. All right, and so then playing it, you'll see you can now shoot a ball and it bounces. and you can't rapid fire unless you set your rate of fire to a really small number, which you can always do over here if you really wanted to have fun with it. And then also, as you turn left and right, it should also go to your left and right, because that's the forward vector is changing as we rotate. Cool. So now let's get some enemies in here. So we are going to create a new object. I'm going to do another capsule. Put it over here. And I kind of want him to look like a Goomba. So I'm going to scale him down a bit so he's a little small bean. Player, we want to give it a rigid body. Let me open this so I can make sure I'm doing everything correctly. Yeah, we want it to have a rigid body. And then we are going to create the enemy script to give it the enemy. All right, so for the enemy's behavior that we want is Mario enemies, when they're close enough to your player character, you want the enemy to start chasing the player character. In order to do that, it's to the player, and so you'll do public rigid body player as one of the variables. We're also going to want it itself, so we can do some stuff with its own rigid body. Going off of the detection, you're going to want distance for your detection. So that way, if you want it to be something that only happens close up, or if you want it to be even all the way across the map, you can set this up, and then whatever number you get it will be used when we do the distance calculations. And just like the player, we want to give it a speed, the way it has a speed as it's moving around. All right, and this guy is nice. We're going to do another fixed update. So first, we're going to start off with a little check. This is good programming practices. We check to make sure player is not null, because what would happen is when the player dies and you destroy the player character, player becomes null, which just means nothing. And so by making sure that the player is not null, we are avoiding the null pointer exception that could happen. So that's just safety. Then we're going to want to make a vector 3 on the player location. So you would do player location, player dot position minus game object form dot position. Oh, because I can spell, I swear. And so these are between the player and the game object. And then we want the y equal to 0. Oh, because we don't want it jumping up. Yeah, if you don't set the y equal to 0, I'm pretty sure it starts like flying around. So if you wanted flying enemies, then sure, you can get rid of this probably. We'll keep it the way it is. If the player location and magnitude is less than, so this is where the detection distance comes into play. If the magnitude of this distance is less than the maximum detection distance, can speak, then we're going to want to actually go towards the player. And so we'll put it all in here. Quaternion direction. So we'll set up the quaternion, which is stuff that is super annoying and complicated to understand, but just kind of roll with it because that's what game dev is. the quaternion to the rotation it takes to look at the player's location. And then we set the rotation of the enemy equal to that. We also want the vector, let's see, this is game object times speed. So this is the enemy's velocity. We want velocity.y, self.velocity.y. I'm pretty sure I listed this like directly from Blaine, so I'm trying to understand exactly what I'm doing here. Yeah, that makes sense. Okay, cool. So we're getting the velocity that we're going to pass the enemy by just the forward vector and times speed. We set y equal to the current velocity of, because we don't want it to be flying around. And then we set its velocity to the velocity that we created. Yeah, this is the only stuff that you need in the enemy script. So now that you have that, it should work. A quick second so people can type it up. Does anyone have any questions about how any of this works? Cool, I'll move on. So now back in the editor, we got our enemy, which I'm going to rename to enemy so I can actually understand it. I'm going to add the enemy script to the enemy. We want the reference to the player, so we'll drag the player over there. We want to itself, so we'll drag itself over there. And then you can set the maximum detection distance and the speed. Oh, hi bud, what you doing? He is not at the 0, 0s. Make sure it's at 0 on your z-axis, or else he is going to fall off your little beam, just like it did for me. There we go. And we're just gonna bounce around him. So he's just gonna keep following us. Something that I forgot to do when I created the rigid body, I didn't freeze its rotation, so I'm gonna go do that now. And I'm also going to freeze it in the z direction, its position, so that way it doesn't fall off the beam. And I think that is it for this. Cool. Now that we have an enemy and we have projectiles, if you notice, we shoot the enemy, it doesn't really do anything. So now we want to kill this guy. I'm going to do all of that within the player script that we've been creating. So if you go back into the player script, we want to reference, we're going to create a health variable. And since we're inspired by Mario, we're just going to set the health equal to 1 right now. So if you get hit, then you die. And then later on, when we get a power up, now okay, time. We also want invincibility. So if you have extra health, it would be really cheap if it touched us for like a second and then it registered, oh, you got hit twice, and then it kills us, even though it was only 1. So we're going to give ourselves a little bit of invincibility time. Invincible time equals 5. And then we also want the last hit time. This is hit. It's going to work similar to how we did the last fire time, and we kind of like use invincible time plus last hit time to figure how long we should be safe. I got a notification about that. I guess nothing popped up. Oh, should we make last fire time private too? Yeah, I didn't do it on last time on accident. It doesn't really matter. Good programming practice, make anything that you wouldn't change in the editor private. So like last fire time is something that you set in the code, and it's something that you just read it. So you wouldn't really want that to be public. So if you want to set that to private, you can. If you want to keep it public for debugging, so that way you know, it's okay, it's set last fire time or it's set last hit time, you can keep it public. Personal preference, but good practices make that you don't need it to be in the editor. Okay. So let me make sure that we are at a good spot. Yeah, cool. We are going to use this one. So if we scroll on down, we're going to, this is one that you can access if you have a collider. So with the collider, so we're able to access this method. It's called onCollisionEnter. It's a little deceiving because you're not actually entering anything, you're just kind of touching it. That's what enter means in this context. OnCollisionEnter will fire whenever you touch something. So whether that's the ground, the enemies, the power-up, it's going to fire. And you will be passed this collision information. The collision information tells out the object that you're touching, about yourself, about everything involved in the collision. So we want specifically the other object that we collide with. So we're going to do game object other equals collision dot collider dot game object. So what we're doing is we're grabbing in the collision the collider of that we hit, as you can read right there, and then the game that owns that collider. And so when we hit an enemy, this will be the enemy's game object. So then, because like I said, this is going to fire every time we hit the ground or enemies or whatever, we check to see if we can get enemy component from this game object. This just allows us to know if the object that we hit is an enemy. If it's not equal to null, then we know that it's an enemy. If you try to do like dot get component enemy, it will return null, which means that everything in here will not fire. So now we are going to do here if the player dot position minus other dot transform dot position. So this okay, so this is used for we want it to be like Goombas, how we can jump on top of the enemy and that will kill them. So now that we know that we are touching an enemy, we now want to be hitting it from the top, or are we hitting it from not the top? So we would get our position, and we get the enemy's position, and we get the y-axis because that's up and down. If the value is greater than 1, that means that we are them. If it's less than 1, then that means we are at the bare minimum to the side of them. So if it's greater than 1, we want to immediately destroy the other object because we bumped on their heads and they're dead. But otherwise, we want the player to take damage. So I'm just going to write take damage in there and a little, we haven't made this function yet. Okay. So we want this to be its own separate function because we like to delegate tasks outward. We don't want to keep everything in just one really long. So we're going to make a new one called player hit. So in player hit, you want to, just like the rate of fire for the fireballs, if it is greater than the last time you were hit, plus the invincibility timer, you will subtract your health because you got hit and you're not invincible. Then you can detect health is equal to 0, and you want to destroy the game object. You want to destroy the player. But if that doesn't happen, then we also want to set the last hit time equal to time. It's not brutal, and touching us for 1 second takes out like 17 health. So that's player hit. Once you've got that, go down to where we had made that comment and just type in player hit. I'll leave that there for a quick second. Go back down. Hit. So now if we go back to the engine, all right, he's following us. I feel threatened, bop on his head. Or if you had enough of life and you want to end it all, oh, that didn't work. Okay. What did I mess up? Player hit, destroy game object. What am I setting my health equal to 1? Destroy player? I don't think so. Let me check. Player, my health is still 1. Why is my health still 1? Is it not firing? That's literally what I have. Oh, okay. This is something that I forgot to do earlier. So the last hit time is auto set to 0. And depending on what your invincibility time is, that means however many for invincibility, when the game starts, you're invincible. So for the first 5 seconds of my game, I can't be killed. So we're going to do is we want the player to die within the first 5 seconds. So if you open up the start method, private void start, you set the last hit time to the negative of invincible time. This allows you to die immediately once. Can you just set last hit time to -2 from construction? You could, but what you would want to do, so like if we go into the editor and we look at the player, you can set invincible time to you can set this to 100 if you wanted to. To make the program scalable, you want that to be something that is done programmatic. Yeah. Yeah. The key to writing good reusable programs is just to make sure everything's based on the stuff that you put in at the beginning. Show the bottom of the code. Gotcha. The collision enter one. Sweet. And so now I should be able to die right off the bat. Are you kidding me? Oh, my health is 0. It worked for you. Well, I mean, that's good. I'm glad it's working for. Sweet. Okay. It's because I did not do less than or equal to 0. That is. Yeah. Yeah. I guess proper way to do this is to make sure it's less than or equal to 0 in case and your health gets set to like -1. Because if you did equals and your health immediately gets set to -1, you're now invincible for because your health will almost never go back up unless you got a power up, in which case the player would be avoiding all the power ups. So that'd be cheap to have in there. Are you kidding me? We're just gonna wait for this to move away. And there we go. Cool. I don't think I have the projectile. No, I don't, because the projectile is a different script. Is that all for the most part? It is. Cool. But we're going to do one more thing before we take a break. We are going to make the script for the projectile. So if you do new script project, and you open this up, this is a nice and simple one. Just like with the jumping on top of enemies, we're going to do on collision enter. We're once again going to get other is collision dot collider object, and then if the other get component is not equal to null, you would want to destroy the enemy, because you don't want the fireballs to ricochet, unless you do want the fireballs to ricochet, in which case that'd be fun. You're going to want to destroy the game object itself as well. So this will destroy the enemy, and then it will destroy the fireball. And so now that that's created, we are going to attach that to the prefab projectile. And so now, when you shoot fireballs, it will kill the enemy. Okay, cool. So the last real link we have is going to be a power-up. And so we have something that takes away health. Now we're going to have something that adds health. And we are going to do this with, in the player script, if you do private void on triggers, this is just saying that if you go into a trigger area, then it will trigger this function. If you do other.compare tag, and then we're going to give it the tag health. Then you can just increase the health, and you can destroy the other game object. Yeah, we're just checking to see if the thing that we're inside has a health tag, and if it does, then we'll then destroy it. So back to the editor, we're going to create another new object. It's going to be a sphere this time. We're going to put it at the origin, and then let's move it just a little over here. In the collider, a trigger, so that way you can run right through it. And then for tags, we are going to give it the tag health, save. When you create it, it doesn't get added, so you also have to add it. And so once that's there, get that. And then when you play, if we, first off, let me do that. So if we look at our player, my health is currently 1. If I run over to this thing, my health power up is gone. So it's a nice, simple health power up. Cool. So now we are going to start attaching sprites to everything after the settings of the health. Yeah, sure thing. So make sure you add a tag here. You can do it by pressing add tag, and then creating it. And then you're going to have to come back here and make sure it's added. And then the sphere collider you want it to be is trigger set to true. And then, yeah, and then it'll work once you run through it. So in order to make everything look pretty, we're gonna need a bunch of sprites. And so can you repeat where the sprites are?
Yeah, sure. So they are linked in the outline, which I will share the link to that in the chat. The outline link is here. And at the top of it, there's links to sprites. There's a zip folder with a bunch of like character sprites and such. And that can be found here. Well, sprites.
Just ignore what I'm
And
doing. I'm
then,
just bringing in everything.
There's also a background image that is separate from the sprites here.
Then I started with 3D objects just because that's what we've been doing in the past, and it was easier to just kind of like show how it all works in real objects. When it's like, if you actually want to make a game, you don't have to use the 3D objects. It's just something that I decided to do. And then, of course, you could make an entire game out of 3D objects. You don't have to use sprites, but I figured it'd be fun. I learned recently how some of them work, and so wanted to try. Cool. So first, we're going to start with giving the player a sprite. So don't follow what I'm going to do, because I'm going to show you why we're not doing something. If you were to put first of all, you would have to get rid of, in order to put a sprite on something, it can't have stuff like the mesh filter. Come on. Or the mesh renderer. And so if I had put on here, you can see it's there, but then because it's a 3D object, when I start rotating, the sprite is now like sideways. If I go into 2D, you can see I'm standing like that. And so it's like Game & Watch and Smash Bros. You can't see them from the side. Yeah, it's like Super Paper Mario. So we gotta do a workaround for that. And so I'm gonna undo all that stuff that I just did, because we don't want that. We want to see the capsule. So instead of putting the sprite renderer on the player, we are to get a child. And so we're going to create an empty game object and put that as a child of the player. And in that, we are going to put our sprite renderer. Pretty sure that's what I did here. Let me just check. Yes, we're good. And so in here, we'll put in the character sprite. And then let me make sure that I got this right. We also, I think we got to make a script. We got to make a script. This one. Oh, is that a thing? That is a thing. All right. Well, that was redundant of me, but we'll get here. Oh, hold on. I'm gonna create C# script. I'm gonna call it Billboard Player. And so in the Billboard Player script, to make sure that the script is always looking at the camera. And so in order to that, we're going to keep update. We need to reference to make sure that the script is always facing the camera, but it's also looking in the character is looking in the direction that you are moving. And so you need a reference to the capsule itself that we're moving around. You need a reference to, and then this is, we're gonna do this later. We're gonna do this later. I'll do that later. There we go. Okay, so yeah, that's all we need for that. So we want to set the position of sprite, and to do that, position of, no, it's the position of, this is the position of the camera. So vector 3 cam position, new vector 3, update or fix, yeah, fixed update. Thank you for catching that. Game object dot position dot x, game object. So since the camera is the thing in the z direction, in the z axis, we want it'll be the same, but we want the camera position, which you can get by doing camera dot main dot transform dot position dot z. This gets the camera's z position, and so the cam position is just straightforward from the player, but at the same z position that the camera's on. That makes sense. And then if you do transform dot look at cam position up, what this does is this will cause the sprite to look out at us at the camera, but not directly at the camera, because that would cause it to start rotating like the edges of the camera's view. And then it also sets the up vector, because if you look at here, it needs a world up. The up vector is the world up. And then I don't need, yes, okay. And then we also need, so this will always make sure that the sprite is looking at the camera. This will allow us to fit based on whether we're moving left or right. So if you do parent dot transform dot rotation dot Euler angles, it is less than 180. This is just something like the 180 is a value that I got through execution. Rotations are really weird, and if I'm being honest, I don't fully understand how they work all the time, but this is code that will work. So if the Y rotation is less than 180, we want to the component sprite renderer, and there is a flip X. It's a Boolean. If it's set to true, then it will flip the sprite across the and then if the rotation is not that, then we want to do game object dot get component sprite renderer flip X is equal to false. And so what this will do is this will flip it if it's 80, and it will not flip it if it's 180 or greater. And so then where, so we have the game object with the sprite renderer. We want to put the billboard player that we just created in there. We want to drag into parent, so that way it's now referencing where the actual capsule is. And then we want to get rid of the mesh renderer and the mesh filter for the capsule. We're going to keep the capsule collider because this green capsule is going to be its collisions. Too, you could also edit the collider so it like fits the character a little bit better. That's totally personal preference. I'm going to do it just so it can. And then once we start, you'll see the character is there. There we go. I died. And then once that thing moves, you can see I jump. Why can't I jump? I cannot jump. He no longer. Yeah, me too. That's a great question. That was not happening in my other one, so we'll have to figure that out. Oh, I think it's because I changed the collider. It's changed the collider. Big oof. Okay, so don't change your collider. I was wrong about that. If you change your collider, you're going to have to change the 1.01 value earlier, because now that the collider is larger, you need to have a larger raycast. You could probably get around that referencing the collider itself when you do that raycast, but that's stuff you guys can do on your own if you want. Resize it. Yeah, that too. You can also just resize the sprite. That's a very good idea. Did not consider that. Do that. It's bothering me too. Yeah. Thanks, Adam. Cool. And so now everyone should have a player that moves left, can jump, and also shoot out fireballs from its hands. How do I resize the sprite? So when you, yeah, that's something that happens in Unity sometimes. So when you, Luke, when you click the game object, you'll see like this box guy. Yeah, you can resize it through the box. Or you can use scale and position. So now that's pretty much all you do to get sprites. And so then you would do the same exact thing for an enemy. So you would create an empty in the enemy. You would add sprite renderer to the enemy. You cannot add player billboard, because player billboard is going to have some functionality that's unique to the player itself. Let's do that functionality right now. I'll jump back to it. So if you go back to billboard player, we want the player to have a different sprite if its health is greater than 1. So when it gets the power up. So we're going to have to reference the sprites that we're talking about in the script. So in your variables, you're going to want to do public sprite, normal sprite, and then public sprite, powered sprite. And then down in fixed update, you're going to want to do if parent.getComponent player.health is greater than 1. You do game object dot get component sprite renderer dot sprite. This is the sprite of your sprite renderer. Is equal to sprite. And so basically, if your health is greater than 1, then we want the sprite to be the powered up sprite as opposed to the non-powered up sprite. But we also have to do else game object dot get component dot sprite equals normal sprite. So if it's not the powered up sprite, it will normal sprite. And I just want to make sure that my syntax is consistent throughout. There we go. Cool. So yeah, now that you made those variables, you now need to assign them. Normal sprite, drag over your normal sprite, and for the powered sprite, drag over the powered one. I'm using the zoomy character sprite for powered. And so then when you get the power up, you'll look zoomy. And then it also has the effect that zoomed and then you get touched, then you go back down to normal. And so that's how you can determine your health. If you had like a Mario, you would have baby Mario and then powered up Mario. All right. But obviously we can't have this functionality in a billboard script for the enemies. So we are going, oh, hold on. Say I changed the collider for the player. How would I resolve the can't jump issue? So yeah, we're going to do one more script. We are going to make the billboard, I'm going to call it other because we could use it on more than just the enemies, I believe. Yeah, we can use it on way more than just enemies. The beautiful thing, did that open? Hello. The great thing about billboard other is that we already have the stuff for it. If you just a couple of lines of billboard player, the fixed update and the camera position and whatnot, and then you use that. There we go. You can literally just copy your own code, and this is all you need for billboard other. It's this looking position. And so you would attach billboard other to things like the enemies or the power up, and that would allow you to, oh, I just lost the thing that I was looking at. Thanks. Great. Okay. Yeah, there we go. And that would allow you to have the sprites always be facing the camera. And so now that we have that in the enemy, do just what you did with the player, empty game object, sprite. I'm going to make the hit cone logo the sprite for the enemy. And just like before, we're going to resize it a bit so that way it fit within the bounds. And then we're going to add the other. That will allow it to always be looking at the camera. And then in enemy, we're going to get rid of the mesh filter and mesh renderer. Since we need a mesh, we just need the capsule collider. And so now, yours hit cone where hit cone is trying to kill you, and you can kill it. And then you can also do it for the power up. Actually, I want to do it for the projectile. That's the most fun thing. So right now, if you were to shoot the projectile, you only shoot your little spheres. It's been turning invisible for some reason. Did you set the sprites in normal sprite and powered sprite? Because if those values are null, then it will set no sprite as the sprite. Let me know if that fixes it. Could I see it? Yes. So like Nathan in Billboard Player, you should have something put in for character for normal sprite and powered sprite. Yeah. Yeah, I forget to instantiate things plenty of times. So we're going to now change the prefab for the projectile. So tile prefab. And then just like all the other, going to make an empty game object in there. We are going to give it the sprite renderer. Yeah. Alberto wants us to do the green soda here. So I'm going to put the green soda in as the sprite for our projectile. Scale that puppy down. So that way it actually fits in there. And then remove mesh filter and mesh renderer. And then you will have a bouncing sprite can, or whatever you choose as your. And it does a nice little tumble. It's very satisfying. I enjoyed this a lot. And then I think if you up your fire rate, then you can even like hit the can, which is really cool to see. And then I guess the final thing that I need to add is, no, okay, in the interest, I'm going to ignore that. So I can cover the final thing. So right now, all of these sprites are on the same layer. If you open a sprite renderer, you'll see that their sorting layer is all default. This means that the game doesn't really know what sprite to put in front of what. If you were to, for example, create a new sprite and then set the background as this. Oh, well, that was lucky. Let's say that background was in front of everything else on your game. That you can fix that by going to the sorting layer, adding a sorting layer, and then so Alberto, sometimes yes. There are certain things, like in the thing I'm making for the libraries right now, where even when you've changed the Z value, they get rendered in front of things. So the sorting layer is the way to make sure that things are being rendered in front of other stuff. So like this is just another like layer of safety. What the sorting layers do is it determines the order of being rendered. So if you had like a background or a layer that is called background and a layer that is called characters. What will happen is the background layer will be rendered and then the character layer will be rendered. And so the characters will appear in front of the background. So by going to like the new sprite that I made, setting the sorting layer to background, and then going to the player and the enemy, and then setting, oh, it would be that, and then setting their sorting layer to characters, they now appear in front of the background. And then, because I really want to use Luke's lamppost, my ground is behind the background. Let's see, that might actually be the Z value then, because our ground doesn't have a sprite. I don't believe it has a sorting layer. I mean, unless these things have a sorting layer. I'm not sure. No, they don't have a sorting layer. Yeah. It might be based on the Z case, in which case just move the background sprite to a Z layer that's further back. But I want to show the lampposts if you were to do something like this. Let's say you wanted the lampposts on the same layer, but you wanted it to still be in front of the background. The order in layer allows you to keep things on the, but put one in front of the other. Is it fine? No, it's the other way. No? Oh, Lord. All right, cool. So if their Z values are the same, you just change the order. If it is higher, it will be in front. If it is lower, so like -5, it will be behind. I'm kind of breezing past this. I kind of just wanted to like show it to you guys because it's just like extra ways to mess around with sprites and to build an environment for yourself. Start the game. Oh, and then you'll notice the projectiles are behind my background. I would have to change the sorting layer for the projectiles as well. And so if I set it to characters, you're in front of characters. So I set the ordering layer to 5. There we go. Now it appears in front. It would also appear in front of my character if I wanted to. But yeah. Wi-Fi. I like that whenever I have to pick a random number, I pretty much always pick 5. Thank you. But yeah, that is pretty much everything. I didn't really cover the camera. If you guys are interested in seeing the camera, but yes, you could leave it at 0, but it's like I multiple things on the same layer, but you want a specific one to appear in front of the other, you would want to move that number forward. Okay, cool. I'll do the camera then. That's a little extra thing. Let me make sure that I have it all. Camera follow. So we're going to do one final script, which I'm pretty sure I've said for the 3rd time tonight. We're going to name this called camera. No, that's, yeah, fine, whatever. I'll call it camera. In the camera, we want a subject, public float. We want to clamp the Y direction because we want the camera to stop at the ground. Like when I play this, oh, come on. Can you, okay, well, anyways, when I play this, the camera sees below the ground right here happening. So the Y clamp is going to help us out with that. And then in fixed update, first you get the Y position for clamping. So if you do mathf.clamp, spect.position, I'll explain what each thing I'm about to type is in a moment. So what this does is this will clamp a value, which is subject.position.y, between minimum and a maximum value, the minimum value being the clamp that we are setting as a public variable, and infinity because we don't care how high they go, we just care about they go. If you ever had a ceiling, then you would put the ceiling clamp in here. And then you would set, this script is going to go into the camera, by the way. So we're changing the position of the to new vector 3 subject.position.x. We are going to be following the subject, which will be our character, in the x direction. We will be setting the y to our value, and we want the z value to be the same. I cannot spell. And so this is all you need to make the camera follow someone. I'm gonna keep this up here for a hot minute. And you'll just attach this to the camera in your scene, and then for subject, drag in the player character. All right, I'm gonna go over here. Main camera, add component, camp. That was a bad decision on my part. That was a very bad decision on my part. I don't think I can add something called camera. I'm going to rename camera follow. All right, so now I can do that now. Hello. Do you know? Oh, because I renamed the thing. Okay, I just gotta fix this and then I should hopefully be able to have it. Visual, yeah. Okay, cool. Now I can do it. Don't name anything, don't name a script an actual name that already exists in Unity because it will hate you. And so this is where we can experiment a little bit. If you leave Y clamp to 0, you're not going to see any change. It will still follow the character, but you will. So this is where you experiment a little bit. 1 brings it up more. 2, 3, 5's too high. 4 is pretty good. can get as specific as you want. So it looks like 3.8 is like the golden value for me. So what I'm gonna do is I'm gonna play mode. I'll set this to 3.8. I'm gonna drag this up because we want to be looking at the ground. And then when I start the game, boom, it's clamped, and all I see is the beautiful scenery. A long background, like in the example that I had earlier, all I did was kind of multiply this sprite and just had it on, and I would change like the X so it kind of not seamlessly, but it would look like it's just. But yeah, I think that's about it. Does anyone have any questions? All right. Well, that's pretty much all I wanted to show. Yeah. Now you guys have the skills to make 2D stuff. So you can use things like the to in other projects, the enemy script. They're all very easy to just kind of like drop and place in wherever you need. Kind of like what we did with Zaldi and a couple of the implementation here. But yeah, that's it. That's all I've got.